Hey everyone. Today I wanted to showcase a behavior tree I've been working on the last couple of days. I had an idea to build a custom one at work. I thought about it all throughout my shift, and when I got off work, I began to get to work to see what I could do. I had an idea to build one using scriptable objects. I'd never built a custom behavior tree before, but I had used them before. I used those as a reference, and I wanted to showcase that. This isn't a tutorial on how to use behavior trees, or, well, it's not a tutorial on how to make them. If you want to learn how to make them, I can recommend things like Unreal Engine. I use their documentation to help build my own, just using how they discussed how nodes work. Really helped build up my own nodes. There's also this website, behaviortree.dev. I went there today. I found it, and it really helped me build special nodes that I needed to help with my logic flow. So I actually really liked it. Got some pseudocode if you need help, and it basically goes over how a behavior tree works and how you might implement one. They do have tutorials. I didn't follow them along, but looking at them, it does look like you're going to need some C++ knowledge in order to make use of those, because I don't see that being readable for any C# users out there personally, but to each their own. So for mine, to showcase what I wanted to just go over the basics, I have a object in the scene that's going to be the test AI. On it, it's got some basic things. It's got like a nav mesh agent. It's got a collider, and this is for detecting things. It's like its sensor. It's going to detect the follow target, like a player in a way if this is an enemy. It's got test AI, which is just a simple script that hosts the behavior tree and has a reference to the bullet. Normally you put the bullet on something like a blackboard, but that would require a little bit more work. I'd have to start pulling prefabs from either resources or addressables instead of drag and drop in the inspector. And just to keep it simple, I made it just on the enemy. In the future though, I should probably move it to the blackboard just to be better. And then I've got the behavior tree, which takes a top node and then calls that top node, initializes it, and then evaluates it, which gets it running, and then that will start initializing the node next in a queue and go on, so on and so forth. So how the nodes are constructed, I've got a behavior node that's a scriptable object. This is so I can manipulate it in the editor. I wanted to be able to take the assets and drag and drop them for easier node creation, which I'll show here in a second. So I have the node. It's got a reference to itself, its state, just so running success or failed, which is used for the node that calls on it. And then it's got a reference to the behavior tree, because it's going to need some information for some of the nodes, of course. Got an initialize that gets called once right before evaluate, and then it's got the evaluate, which gets operated however the node decides to use it. So I've got all these tasks that I built, and those are all those. So I've got some, for example, like look at, initialize it, get some references like the follow target, and then that is obviously going to be obtained through another task, which is, maybe find target or something like that. And then we have the owner, and then it's just, hey, take the owner, look at the follow target that you have. The simple node to create, and then that way we can implement it into our behavior tree. I have other ones like play a sound, which just take a clip, which is also a benefit to scriptable objects, is I can put objects into the scene into them, like an audio clip, and then play that sound whenever I want in my behavior tree. Okay, so let's start by building one. So how this works is you would just put the top node as your start node and then build everything down from there. So your top node would be just a node built up of a bunch of other nodes. So we go into our nodes. Here's the thing, you have task nodes, those are prefaced with a T, and then you have your decorator nodes, and those are prefaced with a D. Then there's also composite nodes, like your sequencer and your selector nodes, which are prefaced with a C. So if I were just to put, let's say, for example, in the scene I have waypoints. I have 4 of them. 3, 4. Let's say I want to go to them. If I just go move to waypoint, drop that in, and then hit play, you're going to notice nothing happens. And the reason for that is it hasn't found them. All that node does is move to waypoints. But if there's no waypoints to move to, there's nothing, it's not going to move to anything. So we need it to find the waypoints first and then move to it. But right now we only have find and not the move as well. So what we need to do is composite node composes multiple nodes in a certain way. In this case, we want to do a selector node is how we want to compose these. And this way, let's say we want to move to waypoints, and then we want to find waypoint. And the reason, the naming on that wrong. The reason why we do this order is because of how a selector node works. A selector node goes through all of its children nodes, and if any node returns success, it stops and starts over again when it's called. So in our tree, this is going to be the top node, so this gets called first, and then it calls the children node. So the first thing is it's going to get called, and then move to waypoint is going to get called next. That's going to return false because we don't have any waypoints, so it's going to call the next child automatically, and that's going to be find waypoint. That's going to return true. So what's that going to do? It's going to make this whole node return true or success in this case. Then because it's the top node, it gets started from it again. So then it goes back down, and then it goes to the first node, move to waypoint. Well, now we have waypoints that were created from the find waypoint node. So it returns success. It no longer needs to call that find waypoint, which is why we use a selector node, is because we don't need to find the waypoints anymore. Once we find them once, we've got them. That's all we need to do. If your logic needed to keep finding them, you would use a sequence node, so that way it keeps running through both of them. But this logic doesn't, it just needs those two. So we'll have that node and set that as the top node here. As you see, it now starts to move to the target. And then once it gets there, it'll immediately turn and move to another waypoint. And then it'll just keep doing that indefinitely. Let's say we want to add more functionality. Let's say we want to move to the waypoint, wait, and then move to the next one, or better yet, move to the waypoint, play a sound, and then wait. Well, if we just add to this node, it's not going to go past find waypoint, because remember, selector, once it gets to a success, it automatically goes back. What we need to do, or I just need to do there, is create another composite node. This composite node is going to be a sequence, because we want it to do multiple things. We want it to do all of them through success. So we want it to move to a waypoint. We want it to sound when it gets to that waypoint, or no, better yet, we want it to wait, then a sound right before it moves, right? That's going to be our new composite node. And those are the three nodes we're going to take. I like to name it according to what I'm going to put in it, just so it's easier to reference. So move to waypoint. Then we got wait. We'll do a 2-second wait. And then we want a sound. So we have two sounds I've already pre-made. So it's just creating a new task. And then do a play sound. Task, play sound. You get an empty audio clip. You just pick an audio clip that's in your project, and then you attach it to it, and then you have a task that plays that sound. You can just put it wherever in the tree that you want it to play. So in this case, we'll play the saber sound. Is play saber swing. Okay, and then so we need to go back to this one. We'll go ahead and rename it. So it's move, wait, sound, and then it's find waypoint. And then that's just so we can keep an eye on what exactly is going into it. And then we go here and we hit play. And now what it should do, move to the waypoint. Gets there. It'll wait 2 seconds, 1,000, 2,000, play the sound, move to the next one, and then do the same thing. And we can 10 seconds. All right, and then so it'll keep doing that. So let's think about some other logic we can do. I've already got some stuff pre-made. Let's think about doing a follow target. So follows this. Well, some things that we need. First of all, we need a way for the AI to find a target. So that's what this collider is for. And then on the AI, inside the onTrigger is a way to set the follow target. So when the collider, if it's a player, set that to the follow target in the Blackboard tree. So to do that, all we need to do is we have our nodes, we have follow target. Basically says follow target, and then that will basically check to see if it has a follow target, and if it does, then follow it. The range on it, so if it's within 5 units, it pauses. If it's outside 25, it stops following. It no longer has it as a target. So all we have to do to get that working is we can just use a single node. We should just be able to follow target, put that on there. At first it won't have a target, so the node will just keep failing, but there's no null reference error or anything because failing behind the scenes. And if we get near, when we get inside that radius, now suddenly it has a follow target, and it'll keep following it until it goes outside that 25 range. Then it stops, and it's got nothing to do. It's just going to keep failing because it no longer has a follow target until I go back into the range, hit that collider, and then just stay within that 5 to 25, right? And we can do more with that logic. We can then have it, so we have it currently follow. Let's say once it gets close enough, it doesn't just follow, it shoots, right? So we create a node, we want it composite because it's going to be multiple nodes. We want it sequence, we want it to do it in order, so we'll do follow and shoot. E2, follow, targets, and shoot the target. Go into our test AI, we'll do follow shoot. Play, get it close. And gets close, boom. And then once it gets to that 5 where it idles, it starts shooting. Now there's a couple problems here. One, you see that it does shoot towards the target, but only when it moves to it. And that's because it shoots out the forward, and the object hasn't had a chance to rotate all the way if it's too close, right? So, and then another problem you see is it's rapid firing bullets. Like there's a lot of bullets coming out, and that's because it's instantiating a new bullet on the update, is every evaluate. So there's two things we could add here. We could add a look at node to look at the target after you've gotten to it. And the second thing we can add is a wait node. So after it fires, it waits X amount of time before it fires again. That's the great thing about these behavior trees. So I just take my AI, or not my AI, I don't need that. I need to go into the nodes where it has follow shoot. Then we're gonna have, let's see, we wanted to wait that we'll do 5. That's because I also want a sound when you shoot. So we'll just go ahead and spice it up with all of it. So we'll do, first thing we want to do, this is what I like to rename so I can remember what I want to do. So first thing we want to follow, then we want to look, then shoot, sound, wait. That's what we want in our composite node. So we have follow, that's already there. We want look at, we already have a node built for that, which I showed earlier. Then we want to shoot, it's already there. We want to play a sound, we'll go ahead and play the shoot sound. And then we want wait. Go ahead and wait 1 second. So it'll shoot every 1 second while it's within range. So we go into here, right, hit play. We just need to go into range. Once it gets to 5, it's going to shoot every second. It's going to keep shooting until it's into chase range, then it'll start chasing. And the reason it does that is because the node doesn't return success until it stops at that 5 interval. So in between 5 and 25, the node is evaluating or just updating, so it just keeps chasing. And so it never calls the shoot because it's not, the shoot doesn't get called until the node returns success. So in range, success, or inside that 5 unit bubble, success. Outside of it, evaluating, and then outside the 25 range, it's failed and it loses the target. All right, so we have that. And then let's say we wanted to combine them all, right? We could also do that. Let's say it goes waypoints, and then if at any point during the waypoint it comes across the player or the follow target, it starts following it. If it loses the follow target, it goes back to finding waypoints. This all can be constructed with this behavior tree node system. So what I would need is some decorators. That's what these were built for. So the first one is a has target check. So it's just a simple script that checks to see if there is a valid target with the child node. If it does have a target, it runs. If it doesn't, then it returns false. The second one is run target while false. So this script allows me to run a bunch of logic while that and check is false. What's different about other behavior trees is more advanced behavior trees use an event system. So for example, if the AI was patrolling and it ran into my player, it would not immediately stop what it's doing and start chasing. It would continue the current node that it's working on, wait till all that's evaluated, and then go back up the tree. And then when it comes back down, it would realize it now has a player to follow and then run that logic. That's because nothing tells it to stop. So you'd have to create an event-driven system. This is a brand new behavior tree I just built, so it's not run like that. Instead, what I do is a workaround where I have a check node. So what this node does, it says, hey, if I do not have a target, run all this code. But the moment I have a target, stop running all of it immediately. It cancels all of it and then goes back up the tree. It's not event-driven. Instead, it's a little bit different. It's not as performant, but it works for this basic implementation. So how would we create this node or these series of nodes? So we would need a top node that is a selector, right? This selector node is going to run, here we go, has target or run while target is false. I'm gonna have those two nodes. The first one that we want it to run is that it checks the has target, because if it does have a target, we want it to keep playing that first. If it doesn't, then we'll want it to run the second one. So at first it won't have a target. So it needs to run while target is false. Then that needs some logic. Well, what we can put in here then is follow, look, shoot, sound, wait. So it'll play all that while the target is false. But the moment the target isn't false, it'll immediately kick back up and then run the has target logic. And in the has target logic, we need to just put the move, let's see, follow, look, we need the patrol. So wait, sound, find waypoint. What we need to do. No, I've got this backwards. I do. So if it has a target, we want to follow, look, shoot, sound, wait. If it doesn't have a target, if it's run while target is false, then we need to move, wait, sound, find waypoint. I had that backwards. Okay. And then in our AI, we just need to put the top node as the very top selector here as target and together. And what we'll get is a waypoint finding AI that will move to each waypoint, wait 2 seconds, play a sound, move to the next waypoint. Then if it finds the target, it'll move to it and shoot if it gets within that range. Look at it, shoot, wait 1 second. And then if it gets out of the range, it immediately starts moving back to waypoint. In the range, fires. Out of the range, back waypoint finding. And that is the behavior tree system I built. So this is a project that I'll probably be tinkering with for this next week. And then hopefully in time, I'll migrate it to a node-based system. But until then, I will be uploading this to my GitHub at github.com/battledrake. You'll be able to find that in the description below. Go ahead and download it, tinker around with it, tell me what you think. Any comments you have for it, let me know how it goes. I hope you enjoyed this presentation and have a good one. Thank you.